Hello and welcome to this video. We are going to discuss nonlinear equations in this video. And just disclaimer here, my power is out, so if my laptop battery dies on me before I am done with this video, it might end abruptly. But if it does that, I will create another video and pick up where I left off once the power's back on. So anyways, for nonlinear system, obviously the name kind of gives it away. You are not dealing with a linear system. You're dealing with a system that could be maybe a parabola, let's say a parabola and a line. Okay, so one of the equations might be a line, but they're both not going to be a line. Or you could have maybe a circle, okay, with a parabola, okay. Maybe you have two parabolas, one this way and one that way, okay. So like I said, the name kind of gives it away. You're dealing with things that are not linear, but as far as solving systems go, you're looking for those intersection points. All right, so you can see here where I'm indicating those intersection points. So when you solve a nonlinear system, you may only get one solution. You could get two solutions. You could maybe even get like four solutions. It just depends on the type of system you're dealing with. But the algebra will take you there. Okay, so if you just do all of your algebra correctly, you will get to all of the solutions. Okay, so if you look at example 1 here, you will see that we have a system of equations, and this first equation here is actually a circle, and then this second one is a line. Okay, so if you just think about a circle and a line, they're asking over here, could we have no solution? And that's possible, right? Like if you have, let's say the circle is right here. Oh, sorry, that's kind of messy. But then the line is over there. Okay, so there is a situation where the line may not actually intersect with the circle. One solution could possibly look like, let's see if I can draw this a little bit neater. All right, so let's say the circle's here, and what we have is what we call a tangent line, where the line only intersects one time. Sorry, it's very shaky there. Sorry. My stylus is jumping around on me a lot here today. So two solutions would be kind of what we looked at up there, where you have the line going through. Okay, so anyway, you could have, the algebra could turn out a lot of different ways here, right? So you just have to be ready for whatever the algebra is telling you. So we're going to use substitution, and we're going to solve for the y in the second equation. And we've done this before, so this is nothing new. All right, you get y equals 3x minus 10. Then use substitution, flip over to the other equation and substitute this in. So I'm going to take the y out, put in the 3x minus 10, and then I'm going to simplify this down. And since I'm now down to just one variable, you can see just x's, I can go ahead and solve for x. The 100s end up subtracting out. Excuse me, and then I can factor out a 10x, and I get 10x equals 0, x equals 0, x minus 6 equals 0, x equals 6. So I'm getting two x values, okay? So that tells me that I'm going to have at least 2 points. Okay, so I need to figure out what's going on when I use an x value of 0, and then what's going on when I use an x value of 6. So you want to substitute back, And this spot right here is going to be a nice place to use, okay? So if I have x equals 0, you can see I'm going to get y equals -10. Okay, so I can fill in this spot over here. That's going to be y equals -10. And then I can repeat the process with an x value of 6. And you get a y value of 8. So that goes over here, y value of 8. So these are my two solutions. And if you were to look at this on Desmos, I'll just add that up here. I always look at these on Desmos. It's a nice way to check your solutions. Your circle is centered around the origin, and you have your line coming through like this. And you'll see on Desmos that this point down here is the 0, -10. And then this point up here is 6, 8. Okay, like I said, Desmos is... Alright, so when you check your solutions, you want to make sure you check in both equations. So if you take the point 0, -10, and you plug this into each equation. So the first equation, I'll have 0 squared plus -10 squared, and we want to see if that equals 100. And you are going to get 100 equals 100, and that checks. And the second equation, you're going to have 3 times 0 minus -10. We want to see if that equals 10, and you're getting 10 equals 10. That checks. And then for your 0.68, go into both equations. So you have 6 squared plus 8 squared. Does that equal 100? You get 100 equals 100. So yes. And then the next equation, and you get 8, sorry, not 8, you get 10 equals 10, which makes that check. All right, and so if you are going to check algebraically, make sure you check in both equations with both points. Sometimes you can have a point check in one equation and not the other, and your answer is obviously wrong because it's not checking in both equations, but it can feel like if you only check it in one equation, it feels like you have the right answer, even though you might have the wrong answer. All right, so what I want you to do is try example number 2. Pause the video, work through it on your own, see how you do, and then you can play the video and see how you did. Okay, so here is the solution. Hopefully you paused the video and you tried it, and you are going to compare with what I have here. And I did use substitution, and I solved for the x in the second equation. And then you can see where I plugged that in and solved down. I got y equals 0, y equals 2. And then I found each of those x values that go with those y values, and those are the solutions to your system. And then once again, it's always a good idea to put it on Desmos and see what it looks like. Okay, so let's keep going here. And when you are solving systems of equations, one of the things that you want to keep in mind is you can actually use substitution, addition, or graphing, right? As we've been looking at Desmos. But substitution works well sometimes, like you saw in example 1 and 2. But sometimes the elimination or addition method actually works well depending on the system. And so I'm going to show you a couple of those examples. So for example 3, one thing I want you to notice is that the variables are set up in the same way. You have an x squared and an x squared in each equation, and you have a y and a y. So whenever your variables are the same with the same exponents in each of the equations, you can use elimination method. So elimination is pretty much exactly the same thing as what you've done in your previous system work. You have to stack up your variables and then eliminate either x or y. In this case, I'm going to eliminate my y's. So I'm going to multiply my first equation by a -7. And then I'm going to multiply the second equation by a 2. And that will make my y variables eliminate. So let me fill these steps in. Now, one thing you'll notice is a little different on these nonlinear systems. As you see here, we got down to an x squared. So remember, we've had this happen before. You want to make sure you take the positive and negative root. Okay, and you're going to get two x values. Okay. And so we want to make sure we use both of those x values to find our y values. So down here, I'm going to use x equals 4 and then pick one of your equations. Let's say you use the first one, plug in that 4, and you're going to solve down for your y variable. And you get a -11. So that's telling me when x equals 4, I get a -11 for my y, and that's going to be one of my solutions. And then I'm going to repeat the process with the x equals -4, which is going to end up being the same thing, right? When you square a 4, you get 16. When you square a -4, you get a positive 16, so it's the same thing. So that's going to give you y equals -11. Okay, and so when you have an x value of -4, you get an y value of -11. And this is two parabolas. Okay, so you have a parabola, it's kind of taller, and then you have one that's a little bit lower. Oh, that is really rough there. That is so hard to draw with. Let me actually redraw that. It's so hard to draw with this stylus. I really miss my dry erase board sometimes. There we go. That's a little bit better. And the other parabola is like this kind of. So there you go. There's your 2 points. Okay, like I said, Desmos would be a great idea there. Okay, so for example 4, I would like for you to try this on your own, see if you can get the solution. I'll give you a hint there. There are 4 solutions to this one. All right, so see if you can get those. Pause the video and I'll see you in a minute. Okay, so here's the solution, and I used the elimination method and I multiplied the second equation through by 5 so that the y variables would eliminate, and you get 2 x values plus or minus 1. Okay, and then I took the positive 1 and I found the y values, and what happens is you get 2 y values. So when you have an x value of 1, you get a y value of positive 2, and then you also get a y value of -2. So that's actually 2 points. And then I repeated the process with the x value of -1. And you can see once again I got the positive and -2. So I got 2 more points. So here are your 4 solutions. And I encourage you to put this on Desmos and take a look at it so you can actually see these 4 solutions. It's kind of an interesting looking graph. So ask questions when you have them, and I'll see you in the next video.